This time we have to find a Ka value from knowing the solution concentration and the solution pH. So these two values are going to be important, and it's going to look a lot like things we've done before. You're going to see your ice equation again. So I'm going to pause the recording to write out the formula. So you'll see there's a very lengthy acid formula. So again, it's going to donate a hydrogen to water. So we have our lactic acid formula. Here, this is your acidic hydrogen here, reacting with water. So we've lost the hydrogen here, so that same long formula. Okay, it's lost a hydrogen, so it is going to be negative, and that hydrogen is added to the water molecule to form hydronium. So we know I have an initial value of 10 for the lactic acid, 0 for each product. Again, the shift is going to be towards product. So subtracting X from the reactants, adding X to the products. Now this time we don't have a Ka value to get into, but we do have the pH. So we do know what this value is. So if the pH is 2.43, and pH is the negative log, if you look on your calculator, you'll see that 10 to the x is the inverse of your log function. So you're going to take 10, because it's a negative log, to the negative 2.43 power. And you're going to get an hydronium ion concentration of 0.0037. And that's really what your X is equal to. So these two both become 0.0037 for both X's, this one and this one. Again, we're going to subtract this, but if you look at the addition rule for sig figs, we're not out to the thousandths place, so this one's going to stay 0.1. So my Ka value is going to be the concentration of the lactate ion. So that's the 0.0037 times my hydrogen ion concentration, which is also that value. And you can write this as squared. It's okay if you do that and just square it because they are the same. All of that over 0.1, and that's going to give you a Ka of 1.4 times 10 to the negative 4th power. For this last problem, you're going to see a little bit of different values. We're creating the solution from a solid, so we have 9.90 grams of the weak base hydroxylamine with its formula to produce 500 milliliters of solution. And we know the pH of the solution is 9.904. So we still have our initial equation, so NH2 OH plus water again, it's a base, so it is going to accept a hydrogen from the water, so you're going to see NH2OH2. That's going to become a plus because it's added another hydrogen, and if we take a hydrogen off of water, we're left with hydroxide. So normally we start with a concentration here. We're going to have to calculate that one this time from our data. So I need a molarity, so I'm going to go moles over liters. And I'm going to put the 500 milliliters in here. And if you're okay with converting that to liters in your head, that's fine. But if not, I'm going to give you the steps. 1,000 milliliters per liter. And then I'm just doing the molar mass, so I have to give you this formula to get this. So 1 mole is 33.04 grams. And when I calculate that out, I get 0.599 moles. So that's going to be my initial concentration. Again, these are both 0, so we are looking, as always, for X. X gets lost a lot. Okay, so this time again we have a pH value. So remember that is the concentration of hydrogen. So to get hydroxide, I need to subtract 14 minus the 9.904, excuse me. And that's going to give me a pH of 4.096. So again, I'm taking the inverse log, 10 to the minus 4.096. And that's going to give me my H plus concentration of 8.02. Excuse me, my LH concentration. My LH concentration of 8.02 times 10 to the minus fifth. So remember the number before the decimal point is just for the power, so my sig figs are coming from these 3 decimal place values. So that's going to be my value here. And also here. And again, you're going to see that this value is so small. This is still going to be 599, so insignificant. So then my Kb value equals my 8.02 times 10 to the minus fifth. And again, I can write this twice like I did on the last one, or I can just square that. Sorry, that is a 5. And then all of that over the 0.599. Pretty bad number. And when you calculate that out, you get 1.07 times 10 to the negative 8. Okay, there's a problem set there. You can work on that and check Firefly or the board for a due date.